All right, let's look at this last logarithmic equation. In this example, we have a natural log on the left side, and then on the right side, we have a constant plus another natural log. When our equations for logarithmic equations have a constant, you want to be sure that you get the logarithms on one side and the constant on the other. So to begin with this problem, we're going to subtract natural log m minus 3 to both sides. We'll end up with natural log of 3m plus 1 minus natural log of m minus 3 equaling 2. And when we're solving logarithmic equations, we want to write these as single logs. If you have multiple logs on one side, condense them into a single log. So we'll end up with natural log of 3m plus 1 over m minus 3 equaling 2. And so now we can do either approach similar to last time. We can e to the both sides, or we can convert these to exponentials. So in either case, I'm going to end up with 3m plus 1 over m minus 3 equaling e to the second. All right, to solve this logarithmic equation, what we want to do is multiply get the denominators the same, so I can multiply m minus 3 on the top and bottom. And it might be really tempting at this point to evaluate e squared as a decimal, but this decimal is going to go on forever, so I would encourage you to just keep it as that constant. We'll end up with 3m plus 1 equals, and then distribute the e squared m minus 3e squared. And remember, we're solving for m, so we'll subtract e squared m to both sides. So I'll get 3m minus e squared m plus 1 equals negative 3e squared. I'll subtract 1 to both sides so that I can now play with this side a little bit more. E squared m equals negative 1 minus 3e squared. So at this point, I'm still solving for m. To do that, I see that there's an m in each term, so I can factor out an m. I'll then be able to divide both sides by 3 minus e squared. Negative 1. So I'll end up with negative 1 minus 3 e squared divided by 3 minus e squared. And this is my answer. And so to check that this is your answer, like we were in those other problems, it's going to require a lot of algebra. What I ended up doing was just approximating this, getting about 5.28. And another thing that you can do is get this in your calculator, get the exact answer, store it, and then plug it into the left side, get that answer, and then go 2 plus natural log your stored answer minus 3, and then you'll see that these are the exact same thing. And so this is our answer. Alright, so we'll work on some exponential equations in the next few videos.